All right, we're in 4.4 on page 213. And we did problems 1 through 12 on Friday. Did everybody understand that? Yes? So I don't have to do problems 2 or 4 or 6 or 8 again? Anyone want to review? You got it? Which one? Addition or subtraction? What? Both? Did you say both? Okay, let's do number 4. What's 1 plus 1? In your head, what's 1 plus 1? 2. How do you say 2 in binary? Okay, now see, you don't have that in your head. So you make a chart. See this little chart on the screen up there? 1 in decimal is 1 in binary. 2 in decimal is 1 0 in binary. Remember, binary is 2 to the 0, 2 to the 1, 2 squared. Place values for binary. So you have to have a chart because you don't have it in your head. So how do you say 2? 1, 2, and no ones. How do you say 3 in binary? 1, 2, and 1, 1. So you write 1, 1 in base 2. In base 2. How do you say 4? Here's the 1's place. Here's the 2's place. Here's the 4's place. So you go 1, 0, 0. Everybody follow that? How would you say 5? 1, 0, 1. Does everybody see that? How would you say 6?
1, 1, 0.
1, 4, 1, 2, and no ones. Does everybody understand the process of how you would just count in binary? Okay, now since you don't think in binary, you're going to have a little chart like this on your paper next to you while you're doing these problems. So let's do number 4 now. What's 1 plus 1? 2. How do you say 2 in binary?
1, 0.
Put down the 0 and carry the 1. What's 1 plus 1 plus 1? 3. How do you say 3 in binary?
1, 1.
See how when you got the chart there, it just jumps right off the page at you. So I put down a 1 and carry a 1. How do you say, and then 1 and 1 is 2. How do you say 2 in binary?
1, 0.
Put down the 0, carry the 1. How do you say 1, 2, 3? How do you say 3 in binary?
1, 1.
There you go. So there's your answer right there. 1, 1, 0, 1, 0 in base 2. So that's why if you were looking at the page and saying, I don't know how to do this, you don't have the stuff in your head, you have to make a chart and put it right there on the page next to you. Do you see the process? Do you see the technique for doing this? Once you've got that down there, once you've got that information there, you look back and forth, and you can translate from decimal to binary. That's what you're really doing, is you're just translating from one language to another, from the decimal mathematical language to the binary mathematical language. Okay, now let's do a subtraction. I know subtraction gets a little tougher because you have to borrow, but that's also true in decimal, isn't it? Okay, so let's see what happens here. Let's do number 8. Now I have no ones. This is the ones place. This is the twos place. And this is the fours place. Okay? So I'm going to change to blue here. I can't take 1 from 0. So I borrow this 2, which leaves me no 2's, but that gives me 2 1's. Do you see that? 1, 2 is 2 ones. So what's 2 ones minus 1, 1? 1. Now, I don't have any 2's to borrow from. I mean, I can't subtract 1, 2 from no 2's. So I come over here to the 4's, and I have 1, 4. Now I have no 4's, but 1, 4 gives me 2 2's. Agreed? 1, 4 is 2 2's. Back to your chart up here. The place values. Maybe you need to make a place value chart too, so you can look at this stuff. So then I have 2 2's minus 1 2, that leaves 1. And there's none of these to come down, so the answer is 1 1 in the base 2. When you borrow in the decimal system, you bring 10 over. You follow that? Because it's the base 10. When you borrow in the binary system, you bring 2 over. And then do the math. Okay? All right. Do you want to do another subtraction or addition? Yes or no? Do we have a handle on it? Okay, let's do number 10. What's 1 minus 1? What's 1 minus 1 in any math?
0.
0. So we put down a 0. What's 0 minus 1? I can't do that. So I borrow here. That becomes 0. What did that? What's that all about? Where'd it go here? Oh man. Ah, come on. So why would this thing be doing this to me? Did I touch it wrong? Am I using a wrong tone of voice or something? Does anyone know why this thing would be doing this? It doesn't like me? Okay. Let's come back down here and see if we can get it. So I had, and this is, okay, this is the 1's place. This is the 2's place. This is the 4's place. And this is the 8's place. So I borrow this 4. Now I have no 4's, but I have 2 2's. So 2 2's minus 1 2 is 1. 1 2. 1 in the 2's place. Now I don't have any 4's to subtract this 4 from. So I come over here and borrow this 8. So I have no 8's, but I have 2 4's. 2 4's minus 1 4 is 1 4. So there's nothing to bring down, so it's 1 1 0 in the base 2. Everybody follow the process? So let's do some multiplication. All right, number 14. What's 0 times anything?
0 0.
Well, that's easy enough. So I go 0 0 0. What's 1 times anything?
Anything.
Anything. So I move over just like we do in regular and decimal. So I move over 1 0 1. Then I draw my line and do what?
Add.
Add, just like we do in our long multiplication. Add. So I put down 0 1 0 1. Is that cool? Binary multiplication is so easy because you're only working with 1 and 0. You follow what's going on? Let's do number 18. Okay, let's do this one first. What's 1 times this whole thing? 1 0 1 1. What's 1 times this whole thing? 1 0 1 1. Everybody follow what I'm doing? What's 1 times this whole thing? 1 0 1 1. Draw my line and add. 1. What's 1 and 1?
10.
What? 2. How do I say 2 in binary? What? 1, 0. I put down a 0. Maybe I'll change the color here. So this is 1. This is 0 and carry the 1. What's 1 and 1 and 1? 3. How do I say 3 in binary?
1, 1.
Put down a 1, carry a 1. What's 1 and 1 and 1? 3. So that's 1, 1 again. What's 1 and 1? 2. That's 0, carry the 1. What's 1 and 1? 2. 0 and 1. So there's the answer. 1, 0, 0, 1, 1, 0, 1 in base 2. So multiplication isn't all that complicated. Let's do some division. Yeah. Okay, you know how to do division. I've got this divided into this whole thing here. Well, look what happens. There's 1, 1, and 1, 1, so I put a 1 up here, and then put 1, 1 down here, and then what do? Subtract, and that comes out to be 0, 0, 0. So how many times will 1, 1 go into 0?
0.
0. So now I bring down the 1. How many times will 1, 1 go into 1? 0. And what's my remainder? Remainder 1. Everybody follow that? Let's try another one. I'm dividing by 1, 1. So I go, well, here's 1, 1. So I put a 1 right here times 1, 1. Then I subtract, and I get 0, 0, 0. Well, that 1, 1 goes into 0, 0, 0, 0 times, and then I bring down the 1. And 1, 1 goes into 1, 0 times, so I bring down the next one. And now 1, 1 goes into 1, 1, 1 time, subtract, and I have no remainder. 1, 0, 0, 1 in the base 2. Everybody see what's going on? Number 24. Now we're up to 3 places. We don't care how many places they have. So I come over here and say, well, look at that. 1 times that is 1, 1, 1. Subtract. 0, 0, 0. Bring down the 0. And that's 0. Bring down the 1, and that's 0. Bring down the other one, and that's 0. Bring down the third one, and that's 1. So the answer is 1, 0, 0, and then put that down here, and then subtract, and you get 0. So that's 1, 0, 0, 0, 1 in the base 2. So that's not all that hard. Stop when you get to problem 23. That's all you have to do here. I wish they would have given you more practice. Since they don't give you that many problems to practice on, if you really want to get more practice, after you work these, just leave them alone for a couple of days and come back and work them again on another sheet of paper. It'll just help fix in your mind the process. So now we're ready for 4.5. Let's see if we can find that on here. 4.5. On page 221. So what are we doing here? We're doing octal addition. Octal addition. Okay, we probably ought to do something over here. If we're working in base 8, then we maybe need to make a base 8 place value chart. The 1s, 8s, and 64s. Everybody see that? Then we probably ought to do what we were doing a while ago, like with binary. here's the, okay, let me come up here and put, here's base 8, and here's decimal. So 1 and 1 are the same, 2 and 2 are the same, 3 and 3 are the same, 4 and 4, 5 and 5, 6, 7. But here's where it gets messy. In decimal, after 7, we say 8. In base 8, you only have 0, 1, 2, 3, 4, 5, 6, 7. So how would you say 8? 1, 8, and no 1s. So that's why it's 1, 0 in the base 8. Is equivalent to 8 in decimal. So how do you say 9 in decimal? 1, 1 in the base 8. 1, 8 and 1, 1. Everybody follow what's going on? We're counting. See, we made a chart where we counted in binary. Now we're counting in base 8. So what's after 1, 1 in base 8? 1, 2. And what is 1, 2 equal to? 10. 1, 8 and 2 1s. The next one is 1, 3 in base 8. And what is 1, 3 equal to? 11. 1, 8 and 3 1s. Everybody see that? So you need to make a chart so you can see how to count in these different bases. 1, 4 in the base 8 is 12 in the decimal. 1, 5 in base 8 is 13 in decimal. 1, 6 in base 8 is 14 in decimal. Everybody see why? 1, 6, 1, 8, and 6 1s. 8 plus 6 is 14. 1, 7 in base 8 is 15 in decimal. And 2, 0 in base 8 is 16 in decimal. And 2, 1 in base 8 is 17 in decimal. So what would 2, 2 be? 2 8s would be 16, plus 2 more would be 18 in decimal. Everybody follow what's going on? So if you just make a little chart where you've counted in base 8, then you will be able to look at this just like we were doing the binary thing. So when you're doing this math over here, because see, what does problem number 2 say? Add 5 and 4 in the base 8. Okay, what's in your head? What's 5 plus 4?
9.
9. How do you say 9 in base 8? See, you don't see it.
1, 1.
Thank you. If you look at the chart, then you go, it's 1, 8 and 1, 1. So I put down a 1 and carry a 1. What's 1 plus 2, 3 plus 6 is 9. How do I say 9 in base 8?
1.
1, 1. So put down a 1 and carry a 1. And I have 1 plus 4 is 5. 8. So how do I say 8?
0.
What?
Wait. 0.
How do I say 8 in binary? I mean in base 8. What's the chart say? Look at the chart. What's it say?
0.
Look, are you looking at the chart up there?
That. Sure.
You got to have a chart. You can't do this in your head. You got to look up there. What is 8? Right down there at 8. What is 8 equal to in base 8?
1, 0.
1, 0. So you put down a 0 and a 1 in front of it. Okay? Everybody got that? You got to make a chart. If you don't have a chart to look at, you look inside your head and it's a blank slate. Unless you've done this before somewhere. So you can't answer a question without the information on the screen. So let's do number 4. What's 7 plus 2? In your head, what's 7 plus 2?
9.
9. How do you say 9 in base 8 in octal?
1 1.
1 1. So I put down a 1 and carry a 1. What's 4 and 3 and 1? 4 plus 3, 7 plus 1 is 8. How do I say 8 in octal?
1 0.
A 0 and carry the 1. What's 7 and 1? 8. How do I say 8 in octal? A 0 and carry a 1. And what's 5 and 1? 6. And how do I say 6 in octal?
6.
6. Okay? Because we're not in binary now, we're in base 8. All right. Number 6. Multiplication. Yeah. Okay. Look at this. Let me change to blue. What's 7 times 5? In your head, what's 7 times 5?
35.
35. Now the question is, how do I say 35 in octal, in base 8? How many 8s in 35? 4. What's 4 times 8?
32.
32. So I subtract 32 from 35, and how many 1s do I have? 3. Did you get that? Oh, do we need to make a chart for base 8? Oh, we already have it over there. Yeah, we've got it over there. Okay. Okay, I suppose you could make a multiplication chart. Oh, you don't have to. There's one in your book, isn't there? Who cares about those charts? We'll just think it through here. Okay, so 4, 3. So I put down the 3 and I carry the 4. What's 4 times 7? In your head, what's 4 times 7? 28. So here's 28, but I have to add that other 4. So 28 plus 4 makes 32. You see that? So how do I say 32 in base 8? How many 8s in 32? Because remember, I have 1s, 8s, and 64s. 1s, 8s, and 64s. Those are my place values. How many 8s in 32? 4 of them, so I have no 1s. So it's 4, 0 in the base 8. So I put a 0 and a 4, and there's my answer. What do you think of that? You feel powerful? Do you feel like you've pole vaulted over the highest hurdle in the world? Let's do another one. 3, 1, 2 in the base 8 times 6, 5 in the base 8. Okay, what's 2 times 5? Let's just change to green. What's 2 times 5? Or what's 5 times... That didn't change, did it? Let's try this one. What's 5 times 2?
10.
So how do I say 10 in base 8? 1 8 and 2 1s. So I put down a 2 and I carry the 1. You with me? What's 5 times 1?
5.
And then I have 5 plus that 1. What would that be? 6. So I put down a 6. Everybody see that? Then what's 5 times 3? In your head, what's 5 times 3? 15. How do I say 15 in base 8? 1 8 and 7 ones. So I put down a 7 and a 1. And there's my first row. Now, since I'm multiplying here, let's just change this to black. Then I have 6 times 2. What's 6 times 2? 12. How do I say 12 in base 8? 1 8 and 4 ones. So I put down a 4 and carry a 1. Okay? What's 6 times 1? In your head, 6 times 1?
6.
And then I add that 1, so that makes 7. Then what's 6 times 3? 18, right? And how do I say 18 in base 8? 2 8s is 16 plus 2 more, 2 2. So I put down the 2 2 here in base 8. So now I've done the multiplication. Now what do I have to do? Add. So what's, this is the base here. Make that a little smaller. I put down 2. 6 and 4 is 10. How do I say 10 in base 8? 1 8 and 2 ones. So I put down a 2 and carry a 1. What's 7 plus 7? 14 plus 1 more is 15. How do I say 15 in base 8? 1 8 and 7 ones. Put down a 7 and carry a 1. 2 and 1 is 4. And then bring down the 2. So 2 4 7 2 2 in the base 8. Okay? Do you see how you need to have someplace on your paper this place value stuff, and someplace on your paper you need to have this stuff here. You need to take a sheet of paper somewhere and just start counting in base 8. 1 2 3 4 5 6 7. It's the same as decimal. When you come to 8, it's 1 0. When you come to 9, it's 1 1. To 10, it's 1 2. 11, it's 1 3. You see what you have to do is if you'll just take a little time when you start working this exercise to make this little chart, it'll get your head kind of wrapped around the concept of working in base 8. And what you're really doing is you do all of your mental computations in decimal because that's the way you think. And haven't some of you taken a foreign language where you think in English and then you translate into the foreign language? Well, that's what's going on here. We think in decimal and then translate into the other base system that we're working with. And in this case, it's octal. So to kind of get yourself ready for it, just make a little chart of octal numbers and just do enough of them till your mind kind of starts to become comfortable with it. All right, so now we're down to what problem? Problem number 10. Subtraction in base 8. So what do we have here? What's 7 minus 7? That's easy enough. That's just 0. What's 1 minus 4? I'm in trouble. Okay? So watch what I do. I mark out the 6 and make it a 5. And what did I borrow? That's the 64's place. Remember that? That's the 64's place. And 164 is 2 eighths. You follow that? So what do I have here? So I've borrowed an 8 from here, and I have 8 and one more make 9. In other words, I didn't borrow 10, I borrowed 8, and then I take the 8 and I add it to the 1 and I get 9. So what's 9 minus 4? 5. Then 5 minus 0 is 5. So the answer is 550. What you're doing is you're carrying over an 8 each time. So let's come over here to number 12. I have 3 minus 4. I can't do that. So I take the 6 eighths and make it 5 eighths. And I have 8 plus 3, which is 11. What's 11 minus 4? 7. What's 5 minus 5? 0. What's 7 minus 6? 1. And bring down the 4. So now that we're working in base 8, you go, when I borrow, I'm borrowing 8 from the other side and bringing it over here. Is that all they give you? They don't give you much practice with this, do they? Number 14. What's number 14? Division. Well, I can just tell you right now, you're not going to like division. It's just the fact of life. You're just not going to like division. But then, who likes division in decimal? I mean, who likes long division? Give me a calculator. The problem is, your calculator is programmed to do decimal. It's not programmed to do octal division. So you have to do it manually. So, I don't know if anyone taught you this when you were learning long division, but the best way to keep them getting really frustrated with it is just make up a chart of, let's change colors here. We're dividing by 5, so we go 5 times 1, 5 times 2, 5 times 3. And you say, what's 5 times 2? In your head, what's 5 times 2? 10. How do you say 10 in base 8? 1 8 and 2 1s. What's 5 times 3? 15. How do you say 15 in base 8? 1 7. What's 5 times 4? 20. How do you say 20 in base 8? 2 8s and 4 1s. Okay? What's 5 times 5? 25. How do you say 25 in base 8? 3 8s is 24 and 1 1. What's 5 times 6 in base 8? 30. How do you say 30? 3 8s is 24 and 6 1s make 30. So it's 3 6 in the base 8. You see why it helps to have this chart here? Because what's 5 times 7? 4 3. Ah, look at that. I'm dividing 5 into 4 3 5 5. I'm going, hey, 5 goes into 4 3 7 times. And 5 times 7 is 43. Draw my line and subtract. And bring down a 5. And 5 goes into 5 one time. Draw a line, 0, bring down the other 5. And 5 goes into 5 one time. So 4355 in the base 8 divided by 5 in the base 8 is 711 in the base 8. Is that kind of cool? Number 16. Now, see, up here we're dividing by 5. Down here we're dividing by 3, 1. So I take 3, 1 times 1 is 3, 1. 3, 1 times 2 is 6, 2. 3, 1 times 3 is 1, 1, 3. You go, what? What's 31 times 3? What's 31 times 3?
93.
93. So that would be 164. And that would leave 27. And what would that be? No, that's not going to work, is it? No, I'm going to have to do that the long way. Well, too bad. 3, 1 in the base 8 times 3. 1 times 3 is 3. 3 times 3 is 9. How do I say 9 in the base 8? 1, 1. So there's where I get the 1, 1, 3. So now I have, hey, look at this. Go back to red. 3, 1 goes into 7, 3. Oh, let's change it to black since 3, 1 goes into 7, 3 twice. And that's 6, 2. Subtract, and what do I come up with? 1, 1, and then bring down the 4. Let me erase this, get this out of the way. What's 114 divided by 31? See that? See where I have 113 here? So I'm going, okay, I take 3 times 3, 1, and I get 113. Draw my line and subtract, and I have 1, and then I bring down the 2. Can I divide 3, 1 into 1, 2? No, and then I have a remainder of 1, 2. This is all in the base 8. So the secret to division is that you take your divisor and make a table of multiples of that divisor. All right, let's move down to number 18. And by the way, you stop when you get to 23, just to show you how far we go here. Number 18, now we're adding in base 16. So what do I need to do? I guess I just need to make a chart out here. In decimal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, I'm running out of space. Maybe I better move it over a little bit. But if I move it too far, it'd be hard to see it. All right. right, let's move it over here. Decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How far did I go down here? Whoa. 21, 22, 23. What would that be in base 12? No, base 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's next? A, B, C, D, E, F. Now, how do I say 16? Base 16, 16 to the 0, 16 to the 1, 16 to the 2. So that's 16 is 116 and no ones. How do I say 17? 116 and 1 1. 116 and 2 ones. 116 and 3 ones. Oh, get out of here. 116 and 4 ones. 116 and 5 ones. 116 and 6 ones. 116 and 7 ones. 24, 25, 26, 27, 28, 116 and 8. Oop, I can't. Yeah, 8 ones. 116 and 9 ones. 116 and 10 ones. How do I say 10? A. 116 and 11 ones. How do I say 11? B. 116 and 12 ones. C. You follow what I'm doing? I'm just counting in base 16. 29, 30, 31, 116 and 13. That would be D. 116 and 14. That would be E. 116 and 15. That would be F. So how do I say 32? Well, there's 2 16s in 32, so that's 2 0 in base 16. Everybody see how you can just keep counting down and kind of get a picture of what's going on? So now let's come up here and do some, what do they want us to do? Some addition. What's E plus 5? What does E stand for? 14. What's 14 plus 5? 19. How do I say 19 in hexadecimal? 19 is 1 3. So I put down the 3 and carry the 1. What's 3 and 1? 4 plus F. What's F? 15. That's 19 again. That's going to be 3 and carry a 1. What's 4 and 1? 5. So there's the answer to that addition problem. Let's do another one. What's D plus F? What is D? 13. What's F? 15. What's 13 and 15? 28. How do I say 28 in base 16? Well, let's go down here to our little chart we made. What did I say? 28 is 1C. So I come up here. And I'm telling you, this machine, put down a C and carry a 1. What's 1 and 1? 2 plus D. What's D? 13. 15. How do I say 15 in base 16? B. Is that right? What what did I say? 13, 15, F. Oh, we're multiplying. What am I doing?
You never finished problem 20.
Oh, I didn't finish 20 up here. Sorry about that. So 15, jumping down to the next problem. So I've got 28, and then I have 1 and B and A. And what's B? 11. What's A? 10. So 10 and 11 and 1 is 22. How do I say 22 in base 16? 22 is 1/6. So I come over here and put down a 6 and carry a 1. And what's C? 12 plus 1? 13. How do you say 13? D. D6C in the base 16. Are we ready for some multiplication? Looks like that's all they have you do is addition and multiplication. Well, what's 2? What's 2 times E? What's E? 14. What's 2 times 14? 28. How do you say 28 in base 16? 1C. So I put down a C and carry the 1. What's 2 times D? 26. Plus the 1, 27. How do I say 27 in base 16? 27, 1B. So I put down a B and carry a 1. Then I take 2 times 4, and what's 2 times 4? 8 plus 1 more is 9. So there's my first row. Then my second row is just 1 times all of that. So that's just going to be 1 times everything. Well, it doesn't want to change. Is 4 D E. And then what do I do with these two? I add them. And so I have a C. And what's B plus E? What's B? 11. What's E? 14. 25. How do I say 25? Back at my chart. 1, 9. So I put down, well, the C came down. Maybe change this to black. The C came down. So I put down the 9 and carry the 1. Then I have 9 and 1 is 10, and D is 10 and D is 23, because D is 13. Is that right? Yeah. So how do I say 23 in base 16? 1, 7. So I put down a 7 and carry a 1, and 4 and 1 is 5. You see how if you have that little chart, if you just, to get your mind ready, you just start counting in it, then you can work, then you just work your way through by looking back and forth and remembering your place value stuff. And that's all you have to do. We could work one more, I guess. 29A times EOF. What's F times A? What's F? I wrote them up here again so you could see them. F is 15 times A is 10. That's 150. How do I say 150 in base 16? 9, 6. So I put down the 6 and carry the 9. And then I take F times 9. And what's F times 9? 135. Plus I have to add that 9, so that's 144. And what's 144 in base 16? 9 zeros. So I put down a 0 and carry the 9. And what's f times 2? F times 2 is 30 plus the 9, 39. How do I say 39 in base 16? 2, 7. And then what's 0 times anything? Just 0, 0, 0. Then I come over here, and I guess we should change to green. Then I take E times A, E times A, and I get 140, which is 8C in base 16. So I put down a C and carry the 8. And then I take E times 9, and I get 126, plus the 8, 134, and that becomes 8, 6 in the base 16. So I put down the 6 and carry the 8. And then I have E times 2, which is 28, plus the 8, 36. What's 36 in base 16? 2, 4. So I put down the 4 and the 2. And then I just draw a line and add those up. 6, 0, 7 and C. What's 7 plus C? C is 12. That would be 19. That would be 1, 3. Put down a 3 and carry a 1. 6 and 2 and 1 is 9. And then 4 and 2. And there's your answer. And all the time I'm using this chart over here. Well, I got my calculator out when I'm doing this. I just walked through it real fast. But just like when I did F times A, 15 times 10 is 150. You can see that. And then I'm thinking, okay, watch what I do. What's 150 divided by 16? 9.37. So that means it's going to be 9 and something. So when I take 9 times 16, because that's my base, I get 144. So I subtract that from 150 and I have 6. So that's the number that goes over there. I mean, that's the mechanics of how I use my calculator to work through this stuff. If you don't like those mechanics, they give you a couple of charts in here that you can use. But I think it's just as easy to take your calculator and walk through this process. Well, stop when you get to 23. And it looks like we just finished chapter 4. So that means on Wednesday, we're going to go over the practice test on page 224. And on Friday, we'll take an exam over this chapter. What do you think?
Let's do it.
Looks good? Then you'll have nothing to think about over spring break, right? You'll have it all done and just won't have to think about math till you come back and start a new topic. All right. Have a good day. Thank you for coming.